Further experiments show that the overall reaction is the one given below. Calculate the initial rate of change of the I3- species. So we can see our reaction follows the form of the general rate law. And for a first order reaction, this extends to look like this. So the lowercase letters are equal to the coefficients of the reactants and the products. And we see that the reactants have a negative coefficient in front because they're being used up in the reaction. And the products have a positive coefficient because they're being formed in the reaction. So what we're essentially looking for here is this value here. So the rate of change of the I3- species, which is our D, right? And what we know from the equation is we know the coefficient for chlorine dioxide, which is equal to 2. We know the rate of change, which we calculated previously to be negative 7.0 times 10 to the negative 4 molars per second. And that's simply going to give us our answer, which is our rate of change of I3-, right? Because the coefficient for I3, there's an implied 1, so that just cancels out. And we're left with the rate of change. So the rate of change of I3- with respect to time is equal to negative 1 over 2 multiplied by the rate of change of chlorine dioxide, which we calculated to be negative 7.0 times 10 to the negative 4 molars per second. And after inputting that into our calculators, we get a value of 3.5 times 10 to the negative 4 molars per second. So how that would look on a graph is where we have concentration versus time. We're starting out with some amount of A, a concentration of A, which is going to follow a first order decay, while at the same time we have an increase in our product, which is I3. And what the question is essentially asking us is to find the slope of the line tangent at t equals 0 for the I3- species. And that's simply the rate of change of I3 with respect to time at t equals 0.